So we're here down to malware behavior, and we talk about a few techniques of what malware uses downloaders to download stuff and to launch malware. So a downloader is an early stage of malware. Almost every malware is staged. If you make attacks with Interpreter and MSF Venom, you'll see that most of them are staged for the same reason that real malware is, because usually you have only a small foothold. You put on a small file, and that downloads another file, and there are stages of malware coming down. So typically it will use some Windows API calls to download something like URL, download the file, and then WinExec to execute the file it just downloaded. So launchers are things that prepare another piece of malware to run it. Now, the old-fashioned way of just downloading a file to the hard drive and running it from there is dangerous because the antivirus will catch it on there. So the malware here tries to hide the executable somewhere. And what it typically does is put it in the resource section of a PE file. Now, a PE file has the text section, which is executable code, and the data section, which is global variables and things like the heap. And the resource section is for incidental extra things like icons and such that it needs, and is not actually expected to contain code. So it's a good place to put code where it won't be interpreted as code by things like antivirus products and the system. So a backdoor is the most common type of malware. This is the general case. If you infect a box, then you have a secret remote control client, and you can use it to do whatever you want. They often send data out on HTTP port 80, or at least they used to a few years ago, because the most common traffic was port 80 then. I think the most common traffic is now 443. When I was trying to show people Wireshark in another class, it was very hard to find any insecure websites anymore. Almost everybody's moved up to HTTPS. About the only large category of websites I could find that's insecure is Microsoft. Bing and MSN.com are not encrypted yet, but I would think it won't be long before they're encrypted too. I used to use AOL, but even they're encrypted. Yahoo's encrypted, Wikipedia's encrypted. Everybody's pretty much HTTPS now, so I don't know if malware still uses port 80, but if it does, it will soon probably switch to port 443 to blend into the most common background traffic. Anyway, your backdoors can manipulate the registry, mess with Windows, create directories, search on the machine for files, and then there's reverse shell is very common. You can make reverse shell with just a few command line commands, like ncat or netcat. But this is one of the many ways to make a reverse shell. The infected machine calls out to the command and control server saying, please give me commands to execute, and the command and control server passes them in. So that's the point here.
You still need to execute something, right?
You still need to what?
Reverse shell. You need to execute it before, right?
Yeah, you need to execute something that makes the connection. You could use a system utility like Telnet if it's installed, or Netcat if it's installed, or you could write your own network socket connector. But yes, you have to have, that's necessary because of the Windows firewall. The default Windows firewall will block all unexpected incoming packets, but it will let you go anywhere you want to if you initiate it from the inside. So that's why the reverse shell is the most common technique. Because if you have a default Windows firewall turned on, a reverse shell will work fine, but you do have to execute code inside the box. So typically you trip the user into clicking on a link or downloading a file and running it. All right, so if you want to make a reverse shell yourself, then you'd call create process and create a socket to the remote machine. So you make a connection, and then you'd tie it to standard input output and error for cmd.exe, and then you can run cmd.exe commands remotely. You can make a multi-threaded one if you like, with 2 threads, 1 thread for standard in and 1 thread for standard out. Sometimes people like to do that instead of passing both kinds of data down the same port. I'm not really sure why. It might be more subtle. So you have RATCHI remote administration tools where you have a few servers, and each server issues actions to the Trojan, to the the machines that are controlled under its control. You don't typically call these a botnet because the RATs are typically used for targeted attacks against a small number of victims, where you really want to control them one by one. A botnet is where you have some kind of mass attack and you take over thousands or millions of machines, and now you don't bother addressing them personally. You give them a job that they'll all work together on, like mining bitcoins or flooding some server with a DOS attack or something. But you don't really worry about the details of them. The control panels just have this many Windows 98 machines, this many Windows XP machines, this many Windows 7 machines, and something about sort them by speed of internet connection or something, and then you just send them orders like troops. These 1,000 do that, these 1,000 do that, with a control panel. So that's the game. Botnets have many hosts. Rats typically are one at a time, or a small number at a time. And then there's credential stealers. There are various types. You might put on a keylogger, and where you're just going to wait for the user to type in credentials, or you might, and you can steal it from the machine in various places, or you can dump stored data, hunt around the machine for stored files to authenticate them, like password hashes or cookies or things like that. One thing I've heard is a very high value monetary item is World of Warcraft passwords. Because you log into their account and you sell their stuff, and World of Warcraft stuff is worth a lot of real money. So, now your book talks a lot about GINA Interception, which is, the point is Microsoft thinks in general terms. So they had login, where you type in a password, it's compared to a hash in the SAM file, and if it passes, you're logged in. And then they said, well, what if people want to log in with a voice print or a thumb print or a hand geometry scanner or retina scanner? So they had to make some more general way for you to make another gadget and tie it into the authentication system. And you may remember when Windows 8 came out, they actually had a picture password where you take your finger and draw a little picture on the screen, and the shape of that picture would let you log in. So they had this more general thing, and that's it. Graphical identification and authentication lets you have another way to authenticate. And that's msgina.dil, which is loaded by the Windows executable during login. So you can have some other way to log in. And that means you've got a GINA Registry Key that specifies what third-party DLLs will be used by the Windows login process, so you can alter the login process. And therefore, you can capture data from Winlogon. Now, this is intended to make it possible for you to add something else, like a camera or a thumbprint scanner, but you can abuse it to just steal the login from the login process. And that's effectively a man-in-the-middle attack within the machine. So the malicious DLL exports all the functions the real MSGINA does, so that this Winlogon thinks it's calling the real GINA, and it finds that all the functions it needs are there, and they pass it on to the real function, but now you have a chance to steal the data in the middle and pass it, dump it on some third party like Pastebin or something, so you can steal the passwords. All right, so if you see WLX exports from malware, that is probably a GINA interceptor. But these things are probably on the way out because GINA's over. Microsoft got rid of it when they got rid of XP. So only old systems use MSGINA. However, they just replaced it by something else that has another way to do the same thing, which is just an even more general thing called credential providers. And you'll see there's a series of registry keys that have to do with existing credential provider and listing what there are to do the same thing, because they still have the issue that you might add some kind of gadget and that might be your authentication. And there's an example of a credential provider rootkit for Windows 7 at this link here, link of chapter 11C. And what it did was you had the original tiles to log in, and the credential provider added a second set of tiles for the second way to log in. And then they had some way to modify the display to try to make it more easily trick the guy into logging in with this one. This is the one that goes to the malicious DLL that's going to steal your password. That's the original one. And this is by design. Microsoft in general, if you have a thumbprint scanner, it will still offer you the chance to come in with just your password, the usual way. And the thumbprint scanner will be an optional, additional way to come in. So that's you can do that. That's one trick to capture logins. Now, if you want to steal the stored passwords, passwords were at one time stored in just a flat text file ending in PWL, and the Linux community figured out that was a terrible idea in 1975 and wrote crypt to get rid of it. Microsoft figured it out around 95, and they hashed it. But Microsoft chose to use a hash function in 1993, and first they used LM hashes, which were from IBM, and so appallingly weak that you can crack them in a minute or two on a modern machine, because they broke your password into 2 7-digit segments and changed all lowercase characters to uppercase, and then hashed it with a very weak algorithm. So it was possible to do a brute force attack through all the passwords without spending much time at it. So the NT, the new technology, is one round of MD4, because they wrote it so long ago, MD5 hadn't even been written yet, let alone any of the SHAs. And strangely, they never updated it in the 20 or 30 years since. So Windows hashes are a complete joke. They're extremely trivial to crack. If you took the 123 class, you can see that even on like a virtual machine, you can try 100 million passwords per second with a Windows hash because their hash is just ridiculously weak. So the only thing is Microsoft regards themselves as protecting it because I published an article in 2600 to Microsoft. People responded to defend themselves. And they said, oh, our hashes, you can't steal them because they're protected by encryption, which they are, but that was cracked like back in the 90s. And so you have to load a special tool to steal the hashes because they are encrypted by a thing called syskey encryption, but the key is in the registry and you just have to have the right software to find the key, decrypt them, and get the hashes, and that's what these things do. Pwdump and Pass the Hash Toolkit and a lot of other tools steal hashes. Came from Italy, steals hashes, among other things. So any of these things, they'll inject a DIL into the local security authority subservice because the hashes are not available even to the administrator. They're only available to system because the hashes are used before you log in when there is no user account to put them on, and you have to use a system, you have to use a service to get the system privileges to dump them out. But all you do is inject a DIL, get the privileges of that process, and you can get the hash. So this Pwdump injects a DIL into LSASS, and then it calls getHash, which is an export of the malicious DIL, which will dump the hashes, and then it can put them on the screen. That's the name of that. And this thing uses some libraries. samserve.dil is the Windows library to let you access the SAM, which is the Security Accounts Manager file that contains the passwords. And addvapi32.dil has some functions, and there are SAM functions like SAM get private data. And the decryption, of course, is not something anyone is supposed to be doing but Microsoft, so they didn't bother to give the functions friendly names. It's just System Function 25 and System Function 27, and they're undocumented. But in the, I think it was the malware, I think it was the exploit development class, we were just going through WinDebug. And WinDebug is so powerful, it's actually quite easy to open Windows functions and figure out what they do, even when they're not documented. And that's what people have done. They found these supposedly private functions and used them. So here's the API calls used by a Pwdump function. There it is, calling samserve.dil. Remember, the way you start when looking at assembly is start way over on the right to find easy stuff and only worry about the details if you have to. So here you just see the name of the function calls, samserve, addvapi, samiConnect, samr query information, get private data, then system function 25 and 27, and all the rest of these just load the parameters for those calls. So you call those API functions, and that dumps out the hashes. Then what you've got is a hash. You don't have the password, but you can crack it with a lot of tools like John the Ripper and Offcrack and stuff. And Hashcat. What's that?
At this point, it's decrypted already?
No, it's decrypted, but once it's decrypted, you have a hash, which is a MD4 hash. And you have to crack the hash, which is just a matter of guessing passwords until you guess the right one. And now that we have like 5 billion stolen passwords, you can try them all in a reasonable amount of time, and the only passwords you won't crack are ones that really are like 10 or 12 digits of random characters. If you use a password manager and you let your password manager generate passwords that really are like 20 random digits, those are still pretty good. But any kind of password you can remember is pretty much a waste of time if they get the hash. The Pass the Hash Toolkit gets these hashes as well using different API functions like LSA, enumerate, logon sessions. There are various other functions that do access to hashes. And remember, the Pass the Hash function uses the fact that on Windows domains, you can typically authenticate with just the hash, which is a very strange design decision. Public key cryptography and Diffie-Hellman have made it possible for decades to prove that you know a secret without sending the secret over the wire. And why Microsoft does not use them for login, I don't know, but they don't. They send a token over the wire which can be stolen, intercepted, and reused, and they try to say that there's no possible other way to design the system, which doesn't make any sense to me, because the whole point of public key cryptography is that you can send a secret over the wire. You can prove that you have a secret without ever sending anything reusable over the wire. You send a challenge, and then you calculate a strong cryptographic function, mixing the challenge and the password, and send that over the wire. And the person at the other end can decrypt it and prove that you know the password, but nobody in the middle can decrypt it. But somehow Microsoft stubbornly maintains this belief that you cannot use any secure cryptography for the password system. It's curious, but you know, they're a huge behemoth, and it's hard to make them change. Anyway, it's the logical way to make Microsoft change is to make a company and make a better product and then try to sell it to them. That's how it usually happens. Somebody else makes some third-party product, and if it's good enough, then Microsoft will buy the company and build it into Windows. That's what Microsinovich did. Microsinovich started by finding bugs in Windows NT, and he told Microsoft, and they fixed them, so he sent him more bugs, and eventually they just bought his company and built it into Windows because they couldn't get him to shut up, so they added it in. And
how long was that? 2 years?
Oh, quite a few years, actually. Sys Internals was a separate company for a long time, like 10 years, but he proved to everyone who was paying attention that he understood Windows better than Microsoft. So they either had to, sue him and silence him, or buy him and add him in. They invited him into the tent, and now he's a big Microsoft big shot. He's writing. He
got a good deal on that.
He looks happy. He lives like 007. He's got a beautiful wife and a fancy car and fancy clothes, and he zips around writing novels
So
about.
You guys found anything else to bother Microsoft about?
No, he's in charge. He's in charge of Azure now. He was involved in fixing this. He's a big shot.
One question: how about the virtual keyboard and using the mouse so you can't copy the keystrokes?
That's not a bad plan. And we tried it in the lab. There's also anti-keylogger software, which scrambles the key in the system calls, and it does block at least the Python keylogger we had in the lab.
But can't you turn on the disability function?
Yes, you can.
Turn on a virtual keyboard and then not use the keyboard to get the data?
You can, and that would probably not stop an MS GINA interceptor, but it would stop normal keyloggers that look for key presses. Yes, and that's one of the many recommended procedures to protect your password is to use some other input method, like the disability keyboard. That's an old trick, but it's not a bad trick. Another trick that's an old trick and a good one is to use really screwy keys, like Alt 047 or something. So those keys are like pound signs or reverse accent letters from Hebrew or something. And therefore, nobody can crack them because they're trying to use dictionaries of passwords, and they may not think of using those goofy characters.
You can do like a trust, right? USB key, stick with the password or something.
Yes, you can. Yes, and people have cards, smart cards and stuff, and those things all go through GINA and now through that credential provider, the alternative credential provider. That's why the U.S. Army said a couple of years ago that they were going to quit using passwords entirely. They said passwords have hit the end of the road, and we're going to use something else, but they haven't announced what it's going to be yet. But most people think it'll be the common access card. They have a card. The card has like a public key cryptography token on it. That's a whole lot better than a password, is to use your card. And that's right. Your card will be stolen, and so you probably ought to have the card plus a PIN or something. But anyway, that's better than a password. That's why the real secure people, they're SSH. They use certificates, so you never type in a password. And as long as nobody can steal the file with your SSH key in it, nobody can get in your account. Anyway, let's try a few of these eye clickers. And there you go. Poison ivy. What's that? We talked about it in earlier chapters. I don't know if it's that big a deal anymore. It was pretty popular back in the days of XP.
Still works.
I don't think it ever worked very well beyond XP in my experience. I put it on machines after XP and it didn't seem to run too well. I'll quit by 30. Because this was a commercial product. The author sold it, and for $200 he would customize it to get past antivirus and stuff, and he ran a business this way for several years until somebody finally legally threatened him and he made him shut down. But it was just a common rat. It's a remote access Trojan, commercially sold. There was a free version and a pay version. And it became quite popular to take over Windows XP and Windows 2000 machines with this thing. I think it got built into a lot of malware families. So which one will put malware in the resource section? I'll quit at 30. Can you pull that shade down? Dylan, it's going to give me a headache shining in my eyes. Anyway, that's the launcher. It's going to launch the file, and the code is in the resource section. Thank you. And it might be compressed or encrypted too, to make it harder for any your automated security products to detect it. That's good. Thanks. All right. Which one causes the infected machine to send a SYN out to the attacker? Well, I appreciate your sacrifice. I'm quitting at 30. Yeah, I would have given you more time if you told me. That's right. That's right. Well, all right. That's reverse shell, of course. It's more complicated than a listening shell that just opens the listening port, but that almost never works because the firewall will block the unexpected incoming packets. All right. Which one is no longer possible?
Oh,
It's now.
XP machines that run cash registers, don't they?
That's true.
So you're saying no longer possible?
I think they might have even expired. The embedded XP had like 2 years more. I think even those have expired now. I think the only people that are still using them and haven't supported are paying Microsoft an expensive bill every year to get extended support. I think they said for like $600 per machine per year, they'd extend it for like another 2 years.
That's the government.
Yeah, people who really don't want to quit using XP, but Microsoft really doesn't want to keep supporting XP. They're way beyond it, and it's real expensive for them to like stop modern threats on an old OS. Anyway, that's GINA. They don't use GINA anymore. Let's try another one here. All right. Which one puts a DIL into LSASS? I forget what it stands for. Something like Local Service Authority or something. Anyway. I'll quit at 30. All right. And Pwdump and Pass-to-Hash Toolkit both work that way. It is, let me just go back and find out what LSASS stands for, because that's irritating me. The Local Security Authority Subsystem Service. That's mighty hard to remember. Those S's all pretty much stand for the same thing. Anyway, but that's the thing that handles the passwords and the password hashes. So now you can put keyloggers on your machine. Now, if you can put your keylogger in the kernel with a malicious driver, then it's very difficult for user mode applications to find it. This is often part of a rootkit, and of course it bypasses all user-based detectors. Now you can have user-based keyloggers that do not access the rootkit. They're easier to write and they require less privileges to install, and then they're going to have to do hooking and polling to detect the keystroke events. Now you can use a hook function, set Windows hook EX, and that will cause it to send a signal to this function every time a key is pressed, like an interrupt. Or you can use this, get async key state, and this will just tell you if the key is down at this moment. So you'll have to keep polling it like 10 times a second or something to get all the key presses. You can also use get foreground window to get the right window to get the keystrokes. Otherwise, I wrote a thing called the evil keylogger just to demonstrate I could sneak it past antiviruses, and that thing was really weak because it would only catch key presses in the window that it opened. And what you have to do is you have to move over to the windows that other people are opening, like their browser where they're logging into a Gmail or something, if you want to get the interesting keystrokes.
You can't fake it, right? You have two keyboards to make it monitor the wrong keyboard.
You probably could if you had two keyboards, although I'm not sure. I think the keyboard events would probably come from either one. I have seen machines with two keyboards plugged in. They both seem to do the same thing. They like open up Notepad, they both go in there. So I don't think it's actually going to fool anything, but you'd have to try it to see. Anyway, so get async key state will tell you if a key is pressed or unpressed and not tied to an event, and get foreground window will find the foreground window so you can make it the focus and get the keystrokes from there. So you'd have to loop through the keys and do this on some frequent basis, several times a second, and you'd end up with information about what keys were down. You'd then have to take a whole lot of duplicates out of this to figure out what keys were pressed to make a password. So here's what it looks like. Find the foreground window, call async, iterating through all keys, check the next key, a simple loop to strobe all the keys to see if they're up or down.
There might be one more way to fix it, like a screensaver that looks like someone's typing some keys and it will simulate keys.
Yes, you might be able to do that. You might be able to add extra spurious keystrokes.
It's running as a screensaver in the background, and therefore it acts like something is phone is alive.
There's a product that does that for network traffic called Waste that sends a lot of extra traffic to try to fool man-in-the-middle attacks. But the problem with this one is it would cause, like if you're opening a Word document typing, it would type extra junk in the document. And if it didn't, then it wouldn't fool the keyloggers. I'm not sure that would work, but you might be able to do something like that. Anyway, so if you want to identify keylogger, you'll see in strings, you'll have to see some way to mark this, like up and right and down and numlock and page down. Those are pretty good clues that you've got a keylogger. It has to have those strings to record those events. All right, and then there's persistence mechanisms. You have to have some way to make the malware stay on the machine even after a restart, because people will restart Windows machines pretty often for various reasons, like putting on updates or just because it's crashing. And after you put your buggy malware on there, it's probably going to crash more, and they'll have to restart it more. So there are places you can put marks on the machine that will cause the malware to launch, like the run keys. There's quite a few run keys. There's APPINIT DLLS, Winlogon Notify, and SVC host DLLS. I think we've talked about them in previous classes. You can also Trojan binaries. Yeah, we'll go through them here. And Joe load or hijacking. These are all ways to make things load at when the machine boots up. And there are many more. Last I heard, I think there were 31 auto start extensibility point in Windows, and that was XP. I'm sure there's much more now. Just many, many ways to automatically start stuff, even without inventing your own. So the run key is there in the registry specifically to make things run when you start up. Procmon will show all registry malware. If installing malware, you can run Procmon and it will show all the registry changes. And that's one good way to figure this out. You may remember this from like Project 1 or 2. You run Procmon and it shows you everything it's doing. Registry close key, registry query key, these are all the registry changes it makes. And you also have RedShot to just take a snapshot of the whole registry, install the malware, and take another snapshot and see what changed. So that's for this, because if you see what keys it modified, you might easily find the persistence mechanism, because it'll be changing one of these run keys or one of the others that you know about. APPINIT DLLS, these are DLLs that load into every process. Now, we're going to see this next time even more with detours. The idea is that Windows is supposed to be customizable. So suppose you have something screwy, like you're putting your machine in a kiosk at Home Depot, and it's not going to have a keyboard at all. It's going to have like a touch screen with 4 or 5 choices on it or something. Then you'd like to redirect every process to use this alternate input method. So there's a driver or code that has to be added to every process, and that's what this is for. If you want to add some special code to every process that launches, you put it in APPINIT DLLS. And this is what you do if you have something like some exotic hardware, which is not what the operating system expects you to use. And of course, it's cool for malware authors. You could make it just launch your malware in every process. Then there's Winlogon Notify. These are DLLs that are used for Winlogon events. And so these, again, would be used for things like thumbprint login devices and such. These DLLs will be loaded and used, and their exported functions can be called when you're logging in. And this stuff is cool because it launches before you log in, it's not tied to any user account, and it even launches in safe mode. So that's pretty nice if you want to really catch like the administrator password even when they log into safe mode. Then there's SVC host DLLs. These run services that run as DLLs. There are many instances of SVC host running all the time, and the groups are defined in some registry keys. You remember quite a few things. If you go to Process Explorer, you'll see SVC host, SVC host, SVC host, SVC host. Each one of them is running a dozen services. Like this one is running all these services: bits, certificate, group policy, client, IP, helper, and all this jazz. There are many copies of it running. Each one of them provides a variety of services. There's about 100 services running on a Windows machine now, just waiting for various things to happen. And you could add your malware to that list, and there'd just be one more service here.
How about one more way to change it? So, like, is there a piece of software out there that, even though, let's say I don't play music, I don't want to use a password. So I could install a piece of software for logging in that plays music?
I haven't heard of that one, but I have heard of VoicePrint's attempt. That's a science fiction staple for years, is logging in with your VoicePrint. And what people said is this really didn't work because human voices change a lot. You get a cold. Yeah. And it turns out people haven't had much luck doing that. They've tried to make VoicePrint modules, and they haven't really gotten good enough. Facial recognition, though, is really coming because of the terrorism threat. The U.S. military has spent an enormous amount of money to make really good face print recognizers so they can put them at airports and take pictures of people from like 30 feet away walking by and see if they're on the terrorist list. So that's really coming. And that's been around for several years now. You have face print identifiers from the camera to log in.
It could work if you played it with a cell phone.
It could work if you were playing music, it would work. But then I don't think that's a very popular act. Your thumb, because you might not have it. Your thumbprint is more popular.
Well, the OK Google service now is using voice print recognition.
Is it?
Trying to, yeah.
OK Google, you say?
Yeah, yeah. So
What's OK Google?
Google Assistant.
Okay, so you can log in with it?
It'll unlock your phone.
Oh, that's cool.
Your voice. And
Neat. So that's if you have a Nexus or something?
Yeah, or I think most Androids.
Oh.
Enable it.
So it'll now that you log in with your voice?
Mm-hmm.
Neat. Does it work?
Doesn't work.
Sometimes it doesn't.
Yeah, if it's a noisy coffee house, I bet it wouldn't work.
It errors to not working though, which is better than erroring to working.
Well, depending how often you can't want to use your phone and it won't let you in, that would be my question.
I think mostly for like when you're driving and stuff too.
Yeah.
It turns it on automatically. You can make it so it works when you have maps open. So
Yeah, well, that's cool.
driving and stuff.
Well, I'm glad to hear it. So voice print is coming.
Yeah.
Yep.
They're working on it. But it's
Good, yeah. Well, I know they've had, you can talk to the thing on, say yes, say no, say one for this, say two for that, so they can understand speech pretty well. But as far as identifying the user, that's tougher, but I guess they're getting there.
Yeah, you have
With-
to train it with like 3 words or something.
Yeah, with AI coming, I expect this to all get really good, you know. Now we're really getting to where hard problems can be done by computers. Anyway,
I think they're looking for problems to solve with AI. Right?
yeah. Well, they found quite a few,
Yeah.
and I think they now can beat Go, and they now can even beat humans at poker, which was considered to be a big step forward. So they've got chess, Parcheesi, tic-tac-toe, Go, and poker. All computers are better than humans.
Wasn't it chess in the...
And Jeopardy.
Yeah.
And Jeopardy, and now poker. They're really moving into areas where humans thought they had the edge because it involves like trying to see if someone's lying and understanding complex sentences. And AI has got all that. So we're really getting to where AI could do a lot. Anyway, so here you see all these different groups, like the network services. In these registry keys here is where you specify what services are going to run in which instance of SVC host. And as you can see, there's a lot of them. Those ones I highlighted there were the net SVCS's group. And you can just add your malware to this and it will launch along with all the other services in the background. And typically, if you do that, you give it a name that looks very much like a normal Microsoft name. Like I've seen ones that are LSASSS and stuff like that. Just a small misspelling of a Microsoft name, like a 1 instead of an L, so that you won't spot it looking at that list. All right, and these service host DLLs contain a parameter with a DLL value down here with a path, which is Windows System 32 netserve apphost.dll. So your malware can just specify the location of the malicious DLL, and the service host will automatically launch that DLL in memory and run it up there. So it's a handy way to, because, you know, there has to be some way for the operating system to launch all those 100 things it has to launch, and this is it. You can just add yours to the group because every piece of hardware and software and every new version of Windows could be changing this stuff too. Your software could have like another service it has to run. I remember I used to have like an ergonomic mouse with a funny shape, and it had some special service it had to launch to run that mouse all the time. So you can add yourself to a group, or you can overwrite a non-vital service and replace it completely with your malware running under that name, because of course those 100 services, you don't need them all to work. Most of them you never use them. You wouldn't really care if one of them was busted. And so you can detect this with dynamic analysis, like we said, by looking at the registry keys it changes, or you can look for service functions like create service A in the disassembly list and look for calls to that API call showing that it is the malware is creating a service. And a few more eye clickers.
And how many people got 20s for this quiz? No?
Oh, they mostly all get 20s now that it's open book and online. But you know, they don't seem to learning it, so that's the goal. One aspect of this technique is more grade inflation, but yeah, as long as people learn.
Answers were wrong for today, right?
Anyway, so which one of these acts like a keyboard driver? It acts as one. The system interprets it that way. I guess I'll quit at 30. Now wait till 35. I thought there was at least one more coming. All right. All right. And that's kernel mode keyloggers. Remember, drivers go in the kernel, and very little else does. So, which one will use the get async key stake function? Guess I'll quit at 30. All right, and that is a user space keylogger. It is, in fact, a polling keylogger is the best answer. This is the general container, and the most specific technique described here is polling, where it's checking to see if the key is down. That's what that one does. All right. And, all right. Which of these depend on registry manipulation? I'll quit at 30. All right, and it is more than one. It is, in fact, I think all of them. Those are all registry manipulations. This is the run key. This is that whole list of the SVC host groups. This one is the APPINIT DLLs that launch every time you load it. And I think Winlogon Notify was also done through the registry. Yeah, the notify value is here in this HKey local machine. So all of them are done by registry manipulations. And that, of course, is the point of the registry. Microsoft took the old MS-DOS and Linux technique of having these little text files all over the place, like your apache.conf and this, and your resolution.conf and everything, and sweeping it all into this one database called the registry. So everything to adjust the functionality is supposed to be in the registry. So that's logical. All right, so which one can you detect with dynamic analysis with Procmon? I'll quit at 30. This is CNET 126. All right, and you can of course detect them all with Procmon because they all look the same there. They're making registry changes, and you'll see registry queries changing keys. The only difference is different keys are changing. From the viewpoint of dynamic analysis, they're all the same. All right. Which one loads into every process that communicates with the user, that calls user 32? So you end up with many copies of your malware running, which is not what you usually want, but sometimes that might be what you want.
Are you safer in a virtual machine then?
The only thing,
keyboard?
I don't think so, no. I think anything you type into the virtual machine could still be caught,
No,
but things you type in...
Use a virtual keyboard and a mouse it in.
Well, I don't think you're any safer than you would be in a physical machine mousing it in, but the mousing it in might fool keyloggers.
Yeah.
All right. And the only point of a virtual machine is you...
Discretion.
yeah, you can only use the virtual machine for things you don't care about and use the physical machine for real things. Anyway, so more than one, of course... no, not more than one. This is APPINIT. APPINIT is the only one that loads into every process. The rest don't. This loads only into the logon process. This loads one into the services. This just runs one copy of it. This is the one that makes multiple copies, APPINIT DLLs. Every time you load an app, it connects to the DLL. Anyway, let's take a 10-minute break. We'll pick up at 7. I'll stop this recording and make it in 2 chunks. This is 126, chapter 11A.